So hello all, we'll be starting to solve ODE from the year 2022. There are 6 questions altogether. We'll be solving all of them one by one. So let's start. The fifth question. As you all know that fifth question is compulsory one. Like you have to compulsorily solve this. You do not have you do not have any choice to choose. There are altogether two questions in the compulsory part, which says that ODE, even though it is considered as a low hanging fruit, has significant weightage. So let's go ahead. So, so the general solution of the differential equation this can be written in the form of this equation, where PQ are non-zero function of x and C an arbitrary constant. So like the first thought that comes to my mind is through using integrating factor approach we can proceed further. But the thing is that this is a complex term. Like many of the things are quite implicit, like they are connected by different different terms, and it becomes quite lengthy, complex to solve it. Let's see how we proceed, and we'll be figuring out what to do next. So given ODE d2y by dx PYQ. So using integrating factor approach, integrating factor is nothing but e raised to the power p dx. So solution is e p dx q e की power p dx. This is, let's say, 1. Like we have to, we from equation 1 we have to proceed in such a way that can lead us to this equation. Say this is equation 2. So see, there are, if you will observe this equation 2, you will see various unusual terms like differentiation of q by p. Unlike here it is differentiation of q of x, sorry, differentiation of x. Here you will find differentiation of x, differentiation of q by p. So we it shows that like we have to do manipulation in order to get the equation 2 from equation 1. So like I think like when I was solving this question for the very first time, like I felt it was kind of bouncer for me. Like it took time to analyze like how we'll be proceeding further. So as per my experience, since I have solved it previously, so I can say that if you will proceed further from equation 1 to equation 2, it will take time. Like since you are supposed to solve this question around 7 minutes for compulsory question, like almost like 36 minutes are there to solve question number 5, which comprises around 5 questions. So altogether around 7 minutes is there. So if you will proceed in the traditional way, one way it could be like you can proceed via uh, partial integration by parts. It can be solved, but it is quite complex, tedious, I could say. Like it was tedious, like time taking, like how you have to manipulate all these things, and also simultaneously you have to solve it in 7 minutes. Something need to be tackled down. So one another method that I will suggest is that go by LHS RHS approach. Why I would say why would I would recommend this method is like it is easier to come from second to first. If we can show that by manipulation 2 can be reduced to 1, equation 1, it will be very much easier to say that LHS is equals to RHS, and hence the result that we intend to get can be achieved. So let's go to the RHS. Since it is more complex, we will try to simplify it bit by bit in order to reach equation 1. So RHS, how like during the exam time, how it will come to your mind. I think when you have practiced different set of problems, I think it will get you will get a clue that this is something, it can be tedious. So with respect to these kind of problems, you will have a kind of feeling that the traditional way may lead to kind of delay. So by practice, you will be analyzing. Even I could not solve at the very first time. So I had to see the solution. So I would recommend to practice, have patience rather. The LHS is y is equals to q by p minus e raised to the power minus p dx c plus e raised to the power p dx differentiate d by q by p. So what we can do? So we try to simplify this down. So y is equals to q by p minus e raised to the power p dx c. Try to reduce it by parts. Say this is 1 attached here. Say assuming it is as a first function, this is as a second function. Why we are doing, you will come to know that if we do, it will be easier for us to integrate this, because then only we will be directly getting q by p. So e raised to the power p dx integration of second function, that is q by p, minus differentiation of first function e p integration of p dx as it is, and in differentiation of this wala term, so this becomes p dx. Integration of this term q by p. Fine. I think we are all done and on the right track. Yeah, let's see if something erroneous comes into way, we'll be tackling that. So q by p minus e की power minus p dx, sorry, c e की power p dx q by p we have differentiated this, so this becomes like that. Q e raised to the power p dx here. Fine, we will be tackling this, we will be solving that in the later parts. So y is equals to q by p e raised to the power minus p dx c e raised to the power p dx minus let's multiply this all terms. so that there would be cancellation. C e keep raised to the power minus p dx. This term would get cancelled. There would be minus sign here. That's why then only it will get cancelled. Fine. I think we are getting the term that we need. So this term is common between both of them. E power, so bringing that to the LHS, p dx minus c e raised to the power, q e की power p dx. So yeah, this was the term that we need. So here if we will put limits, there will be some constant, say minus c or minus c or plus c, or here you can say that minus c is equal to some other plus c, some another constant. Y is equal to e की power p dx c q integration, so what we need to get, we got, since LHS is equals to RHS, that is 1 equals to 2, hence proof. It was easier, like it was easier to solve rather than doing partial fraction at the very first place. I hope it was clear to you. So moving to the second question, like we have given orthogonal trajectory, we have to show that the orthogonal trajectory of the system or parabola belong to the same system. So this is a very easier type of question. Like what we have to do is that, like first find differential equation, find dE and replace y dash with respect to minus y, because orthogonal set of in set of orthogonal trajectories, the sum of the product of their slopes is minus 1. So product of slope is minus 1 since they are at perpendicular, since they are orthogonal. That's why the slope basically y dash can be replaced by minus or 1 by y dash in order to get the orthogonal trajectories. So just find the differential equation of this one. So x equals to be 4ay plus a. So differentiating with respect to x, 2x is equals to differentiate with respect to x. So 2x is equals to 4a y dash. Okay, so we have to eliminate the constant term. So what we can do is that put x by 2 y dash. This is 1, put 1 in equation. So you will get that x square is equals to 4a x by 2y dash. Fine. Okay. All right. Yeah, y is equals to y plus x by 2 dash. So this x get cancelled. So we are here. X is equals to 4 This becomes 2, 2, 2 by y dash. What we can do is here y plus x by, say we can solve it further, or here also we can put y dash as minus 1 by y dash in order to get parabola, in order to get orthogonal trajectories. So replacing y dash by y dash by minus of 1 point y dash. So this becomes that x equals to 2 by y dash minus y plus minus of x upon. Fine, I think we are all on the right track. So let's call it 3, let's call it 2. So what we can do, we will try to bring we will try to match 3 with by making this. I think it's fine. So yeah, x is equals to minus 2y minus 2y y dash plus x y dash का whole square. So it's fine. Say it is 4. Simplify 3, then I think it will be easier. Simplify 3. X is equals to 2y dash 2y y dash y, say y cancel. Here it becomes 2y dash का whole square. So multiplying, I think it got cancelled. Yeah, the x y dash whole square is equals to 2 y dash x. Yeah, I think 4 and 5 are equal, because if you will bring to the LHS, then 4 and 5, since 4 and 5 are equal, therefore the system has same orthogonal trajectory. You just bring here, you will find that 4 is equals to 5. 4 what we got from replacing y dash by minus 1 by y dash. So this is equivalent to this. Therefore system has orthogonal, same orthogonal trajectory. Fine. So done. It was easy question. So solve the following differential equation of method of variation of parameters given y is one of the solution. So since it has been given that y is equal to one of the solution, it has made our life easier. Otherwise we will have to find the first solution also. How we will be finding first solution? Firstly, we will try to write the equation in a standard form. So what is the standard form? Standard form is equal to dy by dx square p of x dy upon dx q of x is equal to r of x. So if we will divide x square minus 1 to all terms, you will find that dy upon x square, sorry, minus 2x x square minus 1 dy upon dx plus 2y x square minus 1 x square minus 1. Okay, so since I told you that like this term has been given, then like one of the solution has been given. Otherwise we will be solving for this also. Like for that what we can do is that like if we will put this since we have put it in standard form, this is standard form, so we can say that p is equal p of x equals to minus 2 of x x square minus 1, q of x is equals to 2 of y x square minus 1. R of x can be just this one only. Fine. So if so suppose we had this term, this solution was not given, had not been given. So what we can do is that like we have to just do head and trial. Like what we can do that a square plus ap plus q, where is 0 for some a belongs to real number, then then y equals to e raised to the power ax is one of the solution. Similarly, if m, what is the formula, like m minus 1 pmx qx square is 0 for some case 1 case 2 if 0 for some m, then y is equal to x to the power m is a solution, is one of the solution, is a solution. So if you will put m in this equation by putting y is equals to is equals to x and m is equals to 1, so you will be finding that this entire equation becomes 0. But we do not have to show that because it has already been given. So since one of the solution is y is equals to x, then other solution can be found by d2v dx square plus I think it was p 2 by u du by d it was I think du by dx, and it was dv by dx equals to 0. Like firstly we are looking for complementary solutions. Basically the yc will be yc plus yp. Yc is basically y complementary, yp is equals to y particular. Since I'm just letting you know that in order to find the complementary solution, we have to look homogeneous equation basically. So homogeneous is when the RHS is 0. So here there will be no rule of R of x. So we'll be proceeding from here only. So we'll be putting the value of u here, and yc would be uv, where u is given, u is x, u is 1, u is x as one of the solution, and we need to find. So p is nothing but minus 2 upon x square minus 2 upon x square plus 1, 2 by x, du by dx is nothing but 1, so dv by dx equals to 0, d2v upon dx square. So if we multiply it, x square minus 1 x minus 2x square 2x square minus 2, then it's become cut, cancelled. We finally get, I think, yeah, fine, it's nothing problem. So calculation wise we are all done. So dv by dx, so d2b upon dx square, put it on the right hand side, so it's become 2 d2b upon dx square, sorry, d2b upon dx x square minus 1. So let's assume that p is equals to dv upon dx. Why? Because it will be easier for us to solve this equation. So it becomes dp upon dx 2 by x upon x square minus 1, then it's become p. It will be easier for us to solve it. If we will take it here, then it will become ln p. I'm just writing directly, like if you take here and integrate it, it will become ln p 2 dx x square minus 1 integration. So what we can do is that, like, we can do partial fraction of this term and solve this equation. So in order to do partial fraction, what we can do is that x square minus 1 x square plus 1, write it as like a by x, b upon x minus 1, c upon x plus 1. So in order to get a, put x is equals to 0. A would be, you will be getting minus 1. Put x equals to 1, a, b would be nothing but 1. I think we are done, no? Sorry. If we put x equals to, sorry, here it is error. If we put x equals to 0, then a would be minus 2. If we put x equals to minus 1, c will get minus 1 minus 2 1. So the entire equation becomes like that. So ln p is equals to minus 2. If we integrate, then it becomes ln x. I'm just doing direct integration, substituting these values here. So b would be ln x minus 1, c terms would be like ln x plus 1. So and since we have integrated, there will be some constant. Let's constant would be c. ln p is equals to c ln c x square minus 1 x square. Yeah, this is a 15 marker, so we can take 3 cases now. Okay, so then p comes out to be nothing but c x square minus 1 x square. C would be nothing but dv by dx is equals to c 1 minus c x square, if I'm not wrong. Fine. So v is equals to we will be integrating cx minus this would be c2. So there will be another constant that will come up in this equation. So this becomes v. So y complementary is nothing but uv. So u is x, v is this, cx, c by x, c2. So yc is equals to cx square, c, c2x. So if we segregate constant terms, then it becomes something like that. Then let's say c b c1. So this becomes this is the general solution, is the general solution of equation. Now we have to find the particular solution. Since RHS term is also there, had this term would not be there, uh, we had already reached our conclusion, our solution basically. So now finding the particular solution. So in order to find the particular solution uh, using method of variation of parameters, for that we need to calculate Wronskian. If I'm not correct, not wrong with respect to pronunciation, Wronskian. I think it was. So please check it if I'm wrong. So in order to find the Wronskians, C1 is equal to U V dash, sorry, U dash V dash. This is U. So U is nothing but X. This is U. This is V. This is U. U dash is nothing but 1. V dash is nothing but 2x. So functions comes out to be 2x square minus x square minus 1, x square minus 1. Fine. Now what we can do, by method of variation of parameters, y particular, if by method of variation of parameters, if yc is c1u c2v, then y particular is axu vxv, where a we can find out by where a is nothing but minus, I think it was minus v r w integration, bx is u, you can remember it like that, like cross terms, v r w, r we already know, x square minus 1, so we can put it here. A would be like minus v square would be, v square was x square plus 1, x square plus 1, x square minus 1, w was x square minus 1, cancelled, so this becomes x square x cube plus 3, x cube by 3 x, this is A. B would be u was x, r x square minus 1, I think we are correct now, yeah, and x square plus 1, x square minus 1, this becomes x square by 2. So we'll be putting the terms, y is equals to ax u bx v. So y particular is equals to minus x cube by 3 x, u is x, v is x square by 2, is x square plus 1, I guess. So y particular is nothing but x to the power 4 by 3 minus x square x to the power 4 by 2 plus x square by 2. So if we simplify, it becomes like 6 x power 4 by 6 minus x square by 2. Yeah, I think we are correct. So y to complete is equal to yc complementary y particular. So yc is nothing but c1x c2 x square minus 1. Y particular was this term x 4 6 minus x square by 2. Yeah, I think we have done correctly. So this is our final solution.